Okay, good morning everyone. Thank you for coming here, even if today is a national holiday, 한글날. Okay, then let's quickly review what we did the other day, Monday. Monday we discussed the nature of production cost then for a firm. Then actually figure 4 in this page is a summary of the thing. This is additional thing. It's useful to start off from the total cost curve. These two we'll discuss the average and marginal cost on this graph, and then this is a starting point. In general, total cost for any firm looks like this one. So this is quantity, value, or cost in this case. This axis is always x-axis stands for quantity, y-axis stands for some type of value, price, revenue, cost. You can measure in money. So cost is a type of value. So this, one more time, this cost represents the total cost. Then, even if you don't make anything, a single unit, you have to pay some cost. That's what do you call this? This is what we call fixed cost, right? Then from this one, so additional thing, 1, 2, 3, 4, 5, 100, 1,000, 10,000, 1 million, keep going, we have to pay more cost, variable cost. Here, this is fixed cost on the additional thing. Up from this one, we call variable cost. Then what is unique about the total cost in general is initially is concave to the origin, but later on convex to the origin. What's different from this thing, as we all understand? I hope you are comfortable with the notion that this is total cost. This is, let's say this is Q2. The slope on this curve is represented by this Q, delta Q, of course, delta TC. The delta Q, delta TC over delta Q is what do we call this? This is marginal cost. So we are Q2. So one more time, the slope on a curve at a particular point represents the marginal cost at that particular point, Q2. This is Q1. Then slope at Q1 is marginal cost at Q1. One more time. By now, I believe you are comfortable with the concept that the slope at on total cost curve represent marginal cost at that point. So Q1, marginal cost at Q1, Q2, marginal cost at Q2. Then from this unique nature, unique shape of the total cost curve, initially what happens to marginal cost? Initially you start with a certain number, right? Not 0 or not infinity. The point is, even if Q0, this is 0, when at the quantity 0, we have a defined slope right here, right? So at 0, marginal cost, it's not 0 or not infinity, a defined number right here. Because we have a slope here anyway, slope here. So a given slope is marginal cost at point 0. Then slope increasing, decreasing. Keeps decreasing, right? Initially, slope decreases. And then here turns around, increases. Okay. One more time. Marginal cost at a factory initially starts with a certain number. Okay. Not 0, not infinity. Number keeps decreasing and turns around here, keeps increasing. And this particular point we call something like this one. Remember. If this is marginal cost. Marginal cost. Initially we start off with a number, right? And then here up to here, this keeps decreasing, turning around, something like that. So this point, the point where marginal cost is minimum, we call inflection point here. Inflection point. Okay. Then initially, remember decreasing, increasing, turned around right here. Why there is general explanation is initially you can enjoy benefit of division of labor. I think I explained that before. Let's skip that. Then anyway, here you can enjoy the benefit of division of labor. From this time on, why does the MC increase? Okay, one more time. Who is more productive, Kyunghwa or Yerin? So Kyunghwa, if Kyunghwa is more productive, will hire Kyunghwa first, followed by Yerin, and in that order. So as you expand your operation, you have to hire less and less productive workers. That's number one. And then congestion, because here we assume capital is fixed, so you have congestion problem. So that's typical explanation of the reason why MC has this type of shape. Now let's move on the figure 4. On this page, then let's start from marginal cost curve. Just like the typical marginal cost looks like this, and just like J curve MC. Okay, MC, then MC, so up to here, it's a Q1. This is total variable cost. Then total variable cost divided by variable cost divided by Q. This is what we call ABC, right? ABC looked like this initially, something like this one. This goes up like this one. Okay, this is ABC. Okay, now we have to take fixed cost into account as well. So fixed cost is fixed. So as we all know, fixed is a given number, constant number. So something like this one. A fixed cost is Q divided by FC. This is a fixed number, right? So you understand that. This is hyperbola curve. Hyperbola. What is that? Something like this one. Everyone is familiar now, this type of equation. The constant number. This is, you learn this in middle school or high school days. So you call hyperbola. Looks like something look like this. It starts from infinity. So they never meet. This is y-axis, and then this is curve, AFC curve. Yeah. They never meet, but it gets closer and closer and closer. Same here. As quantity increases, that the approach is x-axis, but they never meet, but getting closer and closer and closer. This is what we call AFC. Then summing them up means AVC and AFC, we call ATC. Summing this up, let's say. Summing this up, just vertical sum. Summation, something like this one. Okay. Initially, gap is relatively big. Remember, the gap means ABC and this is ATC. Why is that? ATC equal AFC plus ABC. As the quantity increases, remember this is collapses to 0, AFC, and then the gap between AFC and it collapses to 0, like this. But the two of them never meet, something like that. So by now, I want you to be comfortable with all this most typical nature of cost. Cost here we mean production cost. In general, when we discuss a firm, cost means production cost. So cost is production cost. So this is the typical nature of all different types of cost. Total cost, Okay, marginal cost, total cost, marginal cost, marginal. This is marginal cost, right? It's J curve, looks like a J curve. Remember, this is not infinity or zero. This one. Of course, this is point 0 is inflection point, 변곡점, Korean language. This one, and then this is given. Then you can calculate A, B, C. To be precise, you need to know the calculus, but anyway, the graph looks like this one. Okay, and then AFC, this is easy part, right? Simply a hyperbola like this one, because FC is fixed anyway. You have to pay 10 million won, no matter what your production quantity is. Even if you don't operate, you have to pay fixed cost anyway. That's the definition of fixed cost. So this is a fixed number, hyperbola. Okay, and then AFC, that's easy. Then combination of these two is not difficult either. What I mean by that is this AFC, this is AFC, nothing other than combination of this is FC, no, this is ATC. Average total cost curve is nothing other than combination of, summation of, this is average fixed cost, this is average variable cost. That's the definition, right? Total cost, one more time, nothing other than fixed cost plus variable cost. This is easy. So average, no, Q is average, right? Average, Q. Then this is average total cost, average fixed cost, average variable cost. Okay, focusing about this one. Additional thing I want you to know is that this is MC curve cut through ABC or ATC at this minimum point. This one. This is ABC turns around here. Okay, ATC turns around here. This is minimum. Minimum is this one, minimum. Smallest A. Let's call this A. This is AT total cost star, and this is A. BC average variable cost star minimum point cut through. I explained why this is so. Okay. I don't have time to explain this one more time today. So let's go forward anyway. Incidentally, this point will come to this shortly. And then the minimum point we call minimum efficient scale. Minimum efficient scale is the particular scale of operation Q star where ATC is the minimum. MC cuts through all these minimum efficient scale. In textbook, he just calls this efficient scale. Okay. So this closes chapter 13. Let's move on to chapter 14, today's main discussion. So in a sense, this is a summation of our discussion so far. Then it wouldn't be difficult to understand because in a sense it is a repetition of our discussion so far. So first of all, chapter 4 is firms' behavior in perfectly competitive market, or simply you can competitive in a competitive market, or a firm in perfect competition. Their decision-making process. So to begin with, here we discussed firms' behavior. Okay. Firm's behavior, then firm or household, this is general decision-making principle we understand. What is the optimal decision-making principle? Anyone keeps doing a thing until MB equals to MC. For a firm, this is a firm. We discuss firm's behavior. In case of firm, okay, the benefit to the firm is revenue. So the only reason why a firm operates is to create revenue, right? Revenue is, in the Korean language, 매출액. 매출액 is benefit to a firm. So marginal benefit is represented by marginal revenue. Likewise, we have to pay something, right? No, the firm has to pay something called production cost. So for a firm, MB is represented by marginal revenue, MC is represented by marginal production cost. Putting it differently, marginal revenue is a particular type of benefit. Okay, marginal production cost is a particular type of marginal cost. Then additionally, this is useful to know too. Okay, in the marketplace, 경화 & Company, small firm, is in perfect competition. Then as for a firm, perfect competition is there. Think about that. This firm, 경화 & Company, sells 1,000 units. What is the marginal revenue of 1,001st unit? The market price, right? Okay, so market price is marginal revenue. Then 경화 sells in total 1,000 units of the thing at the market price. What is the average revenue? Same story. Average revenue is the P is the average revenue. This should be clear to everyone. So perfect competition, market price represent marginal revenue and at the same time average revenue for a single firm. Likewise, from the demander's buyer's perspective, you are one of the so many buyers, okay, facing so many firms. So you don't have any control over the market price. You have to buy a thing at the market price. Okay, so market price, so this buying price, right? Demander's case, buying price. You buy a thing at the given market price, that's your marginal cost. Average revenue, you buy 1,000 units of the thing, this average cost. Keep this in mind. Then now we are ready to move on here. So as always, a firm, because a firm's decision making is where it's always at the margin, means the firm to make the optimal decision, a firm should take marginal revenue and marginal production cost into account. So let's start off with the marginal production cost curve. Marginal production cost curve. Okay, this is defined by what? Okay. By the way, production condition is defined by what? Market condition? No, it's defined by technology and factor market condition, and then they are separated from the market of the thing, the product. So MPC doesn't have anything to do with the demand condition. It is solely defined by technological condition of the firm. This is it. Okay. Then this is given to us or to your firm, 경화 & Company, Erin & Company, Mingi & Company is given to you. Define. Okay. Then now, 경화, do you have any control over the market price? Apparently you don't. Okay. You simply take the market price as given. So what if the market price P1? How much would you supply? Or how much would you produce? Here, as I keep saying, production is the same as sale or supply. So market price is P1. What does it represent? Market price, as I explained here, market price is nothing other than marginal revenue, right? So how much would you produce, 경화? Probably Q1. Okay, Q1. So what if market price is P2? How much would you produce? Of course, you will produce Q2. Right? What about market price PC? QC, right? It's straightforward. P3, Q3. Okay? That's straightforward. So actually, this is what we discussed in the past. Okay, so you are so familiar with this. So anyway, here what you understand is that MPC represents your or Kyunghwa's sale plan. But in economics, we don't call that a firm's sale plan. What do you call that? We call supply schedule, or simply supply. So once again, MPC represents a firm's supply schedule. Okay? So no problem understanding this by now. Okay, but that's not the end of the story. Remember, decision making is one thing. Okay, so there's no question about this. Okay, so this will lead you to the optimum result. But if the optimum result gives you that loss, what would you do? Probably you wouldn't do that in the first place. So come to think of it, you have to, a second concern is that whether to do the thing at all. Right. One more time. Optimum decision, all that we know from this marginal thinking, Mankill's principle number 4, is that by thinking at the margin, we can achieve the optimum condition. But optimum condition is not a profit or minimal loss. So which is optimum? Bigger loss or smaller loss? Of course, a smaller loss is optimum, better than, preferable to bigger loss. So what if the optimum condition gives you a loss? You wouldn't do that in the first place. So to understand that, you have to evaluate your decision. So to make the evaluation or decision making, okay, as I explained it before, average is useful, convenient. Okay. So playing with average numbers is convenient to us when we are going to evaluate the consequence of our optimum decision making. One more time, there is no question that thinking at the margin would give you the optimum result. But the second concern is that what if the optimum condition results in a loss or minimum loss? So even if the loss is minimum, you would like to avoid the minimum loss or in any case. So to understand that whether the optimal result gives you a profit or loss, we have to play with average number. So here we go. Let's juxtapose two cost graphs up to here. One was average variable cost. This one, remember, it's cut through here. Okay, let me make it a little better. Okay, this is average variable cost, or average total cost. See, average total cost. Then another one is average variable cost. Yeah, I know you should be comfortable with this one. Two of them approaches here, average. This is variable cost. Okay. Then let's come back to this equation. So one more time, this is average total cost. Okay. This is average variable cost. Okay, let me redraw the whole thing to make it clearer. Let's start off with the marginal cost curve here. Okay, let's make it more dramatic. MC. So additionally we have the marginal, no, average ATC. Oh, it doesn't look like this one. No. ATC. Okay. Now we have ABC. Two of them should turn around here. Minimum right here. ABC. Okay. Now evaluate the result of our optimum decision. Okay. So let's start case number 1. Here, I want you to remember that to make the evaluation, average numbers are useful. Average revenue or average cost is useful. Okay, why that is? One more time. Our interest is in finding out net revenue, or also known as net revenue equal profit. Right? Profit is different name for net revenue. Net revenue is defined by total revenue subtracted by total cost. This is average revenue subtracted by average cost multiplied by quantity. So I believe everyone is comfortable with this equation. Why that is? Remember, definition of AR is Q over PR. A C equal Q over total cost. There's no magic in this equation. So average revenue Q multiplied by Q, total revenue. Average cost multiplied Q is total cost here. No question about that. So, okay, one good thing is this about with this equation is what is the average revenue for? That's P, right? P is market price. AC multiplied Q. So this gives us the beauty of this equation. P is known to everyone, right? Okay, let's come back to this relationship. What if P is P1, P is here, P, let's say P1. No, let's say PA. Okay. So what is the optimum? Optimum will be QA, right? QA. So what is our focus, our interest in knowing this one, net revenue. Remember, okay, our goal is always to maximize net benefit, in this particular case, net revenue. So a firm's goal is always to maximize what? Net revenue, also known as profit, this one. So let's calculate this from this curve. What, in this case, if market price is PA, what is our net revenue? Well, it's relatively easy, right? What is it? Our total revenue. Remember, we sell, or 경화 and company sells this much, this many. We put this one, right? Then this rectangle stands for what? Total revenue. Okay? Then remember, what is this curve? ATC, right? Here, QA, quantity, the area below this one. This one, this rectangle, QA, average price, average cost here. Then this rectangle stands for total cost. Then you can easily understand that, what is this? This is, okay, net revenue or profit. So by doing this, you can maximize, okay, net revenue or profit when P market price is PA. Because that is what we understood from the previous discussion. Previous discussion is that by matching marginal revenue to marginal production cost, we can maximize and optimize our outcome. So in this case, so this is the greatest. Greatest, by doing that, you can secure the greatest profit. Okay, that's pretty clear. Okay, what if market price is here? Okay. Previously, I mentioned this. The point is, what did you call this? This is what called minimum equivalence scale, or efficient scale, or let's say Q star, and P star. Okay, what if the market price falls down to P star? You simply break even, right? Okay, so no profit, no loss. Okay. Then, what if market price falls down here? PB. Okay, this is what this PB is unique is. This is falls somewhere between two minimum points. This is minimum marginal minimum efficiency scale. Minimum point on the ATC curve. This is minimum point on ABC curve. Here. Okay. So market price falls down somewhere here. So this is PB right here. Okay. So our overarching principle of optimum decision is, what is it? It's we keep producing until marginal revenue equals to marginal cost. This is the very point. So this is let's call QB. Okay, we know that if anything, this is our optimum point. So here, shall we? Let's calculate the profit and loss right here. We produce here only as many as QB. This is QB. At QB point, this represents what? This represents our total revenue. Then here, this represents our total cost. Then we record this much loss. Okay. So do we stop operating or do we not? We do not stop operating. That is because, remember, what does this cost represent? Here represent the average total cost, right? Okay, so average total cost multiplied Q is, what is this? Of course, total cost, right? Okay, now let's play the game. So our net revenue, okay, let's play this one. TC, total cost equal, see, average variable cost multiplied by Q plus FC, right? The difference between this item and this item, we have to pay this anyway, but this is proportional to a production quantity. One more time. Total cost consists of total variable cost plus fixed cost, right? Fixed cost, we have to pay this anyway. Then what you can understand is that, remember this one. So this is here. Our decision is QB. So up to here. Here. Our decision is, of course, defined on this MC curve. This is our decision. Then you draw a straight line here. Okay. We produce QB. QB, this is P right here. And this point is average total cost, and this point represents total. Okay, this is A TC star. This represents ABC star. Okay, so then this is very clear, right? We have to pay this cost anyway. Okay. Anyway means even stopping the operation, we have to pay this anyway. then what will happen to us if we produce this much? Remember, this much, this is average variable cost, right? Average variable cost. You have to pay this anyway, or put it differently. Let's calculate. Net revenue equal PB minus Q. This is total revenue, right? Subtracted by total C. And then we come up with this one. PB, okay, PB plus minus ABC Q minus FC. So from this equation, remember this equation, net revenue is this one. This is minus, okay, because price is this, ATC is this. This represents minus. But analyzing it further, equation this one, you have to pay FC anyway. Zero, even zero. So two options. Stop operating. Then you have to pay FC, right? Then keep operating. You produce Q. Then PB, which is bigger? PB and ABC. This is bigger, right? By producing QB, you can reduce your loss. This is easy. So, okay. From the optimum decision, so by keep operating, you can reduce the loss. So, which would you choose? Bigger loss, smaller loss. Of course, smaller loss, right? So, even if you record loss, you would produce as long as PB is bigger than ABC. Okay, that's the point. So that's the point here, that you keep producing until this one. So the minimum point is the, okay, let's call that, let's Q, give a number, P double star. This is P double star is here. Oh, ABC, no, Q double star. Q double star is that the minimum point on this ABC curve. So from this equation, you can clearly understand that in this region, even if you record a loss, accounting-wise, you keep operating here. Is that clear? So up until Q, or the other way around, this is ABC star. So up until market price falls down to ABC star, you will be in operation. Then, what if market price falls down below it? Probably you'll stop operating. So this you will shut down. 가동 중단 in the Korean language. So in sum, market price is below the minimum efficiency scale. You keep operating until MR, which is market price, equals to MPC, and this is optimum. Then as market price falls down, at here MES, you will break even. No profit, no loss. That's what you call break even. You just break even. Break even means no loss, no gain. You just break even from this below, from this direction. From moving this direction, keep at this point you break even, and then at this point you produce more than this, you can record a profit. So that's meaning of break even, 손익분기점. This is break-even point. Sometimes you call this break-even point, 손익분기점. So up until above the break-even point, your decision point is always the point where MB equals to MC or MI equals to MPC. Here, after here, below this market price falls down, you will shut down. Okay. Then shut down 가동 중단. That's short run. But long run, your constraint is slightly different. Okay? Have different long run. Difference between short run and long run is that if the market price consistent base on a consistent base stays here, you will close down your factory. You will exit from the market, and this is the exit point. So here, short run, you will market price fall down below here. You will stay in business, but it continues. Lower price continues. You will shut down. You will exit from this business altogether. So this is we call exit. This is exit. No, this is exit point. This is shutdown point. So this is called 가동 중단, exit, 퇴출. You will 퇴출 from the industry. You will exit the industry. Okay. So this is okay. So to be precise, in the past we defined MC curve is the same as your supply curve, but to be precise, short run, this will be your supply curve because here you will be in operation, but long run, this will be your supply curve. Is that clear? So long run, if market price falls down below, this is key knowledge, key information I want you to know is that if market price falls down below the minimum AVC at the minimum efficient state, you will exit from the market, right? Is that clear? One more time. This is ATC curve. Then this is efficient scale. In the long run, you will exit from the market if market price is sustained here, down below this one, okay, the minimum AVC. Is that clear? So, from this is your long run supply curve. And long run entry is free. If Kyunghwa makes big money, Yerin will jump in, and then Yoongyung will jump in, Mingi will jump in, and Jae-woo will jump in into this market. Then what? So long run, short run supply curve here, you sum them up. But long run supply curve, this is Kyunghwa and Company, Yerin and Company, Mingi and Company, you sum them up. But long run, everybody can get in this market, right? So from this we can understand that this is figure 8 actually. Figure 8. Long run, this is the, let's say, ATC star. So ATC star means the ATC at the minimum efficient scale. This is long run supply curve to the market. So it's simple to understand, right? One more time, because this is kind of repetition of what we have discussed so far. So no, not so serious difficulty to any of you. So before closing today's session, let's quickly go over today's class notes. Okay, so I refer you to bottom of page 6. Firms in competitive markets, before that, from the firm's perspective, there could be all different situations. Number one, we call perfect competition. Our assumption is that, as I write here, homogeneous or identical product. Each firm sells exactly the same product, no difference at all. Then entry is free. Anyone can come to the market to buy or to sell. So if there is an opportunity of profit, numerous firms will jump in the marketplace. So because of this, there are numerous players, demanders or suppliers. No single participant has any influence of the market price. Or putting it the other way around, each and every participant in the marketplace takes the market price as a simply given. Okay, that's perfect competition, 완전 경쟁. Okay, the polar opposite of that is monopoly. There is only one firm in the marketplace. We'll discuss in this next week. Then slightly different case is that there are multiple forms, but each sells a slightly differentiated product. For example, coffee is not the same. The coffee is sold at Starbucks and then in the vending machine or in cafeteria at our school, all different, right? That's what we call differentiated product. And then finally, we'll discuss oligopoly. Theoretically, this is the most difficult case to analyze, oligopoly. 과점. Anyway, we'll discuss different cases next week. Okay, this week's main point is the perfect competition. So again, from the start of page 7, so decision making objective function is net benefit. Is defined by total benefit subtracted by total cost. Okay, then competitive market. Okay, the definition, I refer you to page 290. One point I want you to know is there are few entries, entry barriers. And there are two types of barriers. One is entry barriers or exit barriers. So the barriers define the competitiveness in the marketplace. The simplest case is that think about a steel mill like a Pasco or three-folded restaurant or 삼겹살 가게. So to build a steel mill, is it easy to enter? No, extremely difficult to enter because first of all you have to get a license from the government and then you have to pay enormous amount of money to build a factory. Then exit, is it easy to close down or Costco? No, it's almost impossible because you have to hire bunch of people. So in case of steel industry, exit barrier is very high as well as entry barrier is high, very high too. But in case of 삼겹살 store, is almost no entry or exit barriers. That's the reason why 삼겹살 business is so competitive in any city. Okay, so one more time, exit barriers or entry barriers, collectively we call mobility barriers, define the competitive situation in the marketplace. Okay, so revenue of a competitive firm, I explained this before. Okay, then let's move on to the second page. So, evaluation of performance, don't forget this, top of page 5, don't forget this. Optimum decision doesn't guarantee profit. It may mean minimum loss. So minimum loss, your decision depends on short run or long run. Long run, you can avoid any loss. And then short run, you may want to minimize your loss. So this one. And then sunk cost. Okay, this one. Here we go. The cost you have paid anyway, or the cost you have to pay anyway. You have paid anyway is sunk cost. And actually, to be precise, sunk cost is slightly different than fixed cost, but you may take them the same thing as far as basic economics theories are concerned. So sunk cost is the example of sunk cost. When you buy a coffee can from vending machine, so you pay. How much did you pay for that? 1,300 won, 1,300 won. Now, is there any way for you to return the coffee can to the vending machine? No, you cannot do that. So you have to have paid it anyway. Drink it or not? No, it doesn't make any difference. So that's a sunk cost. Western saying you have probably remember this one. Don't cry over spilt milk, or let bygones be bygones. 과거는 잊어버리세요. That's the lesson to you. Then evaluation Okay, I explained this before. Okay, so three different cases depending on the location of the market price. Okay, so market price is that if market price is higher than ATC, you cannot profit. You can record a profit. Then the market price falls between ATC, minimum ATC and minimum AVC. We can minimize the loss, so we don't shut our factory down. Then long run, we will get out of this business eventually. Okay, then the following page 9. Okay, market supply curve. I explained this before. Okay, figure 7, long-run market supply curve. I made a mistake. This is 7, not 8. So long-run market supply curve. This is 7. Sorry. Long-run market supply curve is this one. Okay, it's horizontal line, not arbitrary. The ATC at the MES, minimum efficiency scale. This is not from change in technology or anything like that, but simply because of change in firms in the marketplace. Here, okay, this as long as firms can produce here, so firms keep entering the marketplace. This one. Not to mention, this is the point. It's zero profit means zero economic profit means normal profit. So normal profit over time means the profit just to compensate enough to make up for the opportunity cost of equity capital. That's normal profit. Okay, then page 10. Nothing for me to add. Okay. Finally, has anyone seen the movie Bonnie and Clyde? This is the story. Very interesting movie. So this is relevant to our discussion next week. The Bonnie and Clyde. Okay. Yeah, this closes today's session. Any questions and comments? Okay, if not, I will see you next week.